Rural areas often experience unstable and unreliable power supply due to weak and outdated grid infrastructure. The electricity network in these regions is prone to frequent faults, breakdowns, and interruptions, which are further worsened by the long distances over which power has to be transmitted from the main grid to remote villages. This not only reduces the quality of power received but also increases the chances of voltage fluctuations and outages. In addition, the cost of maintaining such an extended and fragile grid system is very high, making it economically unfeasible to provide consistent and reliable electricity to all households in rural areas. We use ESP32 sensor nodes to continuously monitor voltage, current, and battery state, eliminating the need for manual checks by enabling automatic real time data collection. A hybrid gateway approach is adopted, where Arduino Uno R4 and ESP32 serve as gateways that are less complex than Raspberry Pi. Data can be transmitted online through MQTT for cloud storage and analysis, or offline via LoRa for long range communication, making the system highly reliable in rural areas with poor internet connectivity. A lightweight machine learning model is integrated to analyze past weather data and provide useful insights through a mobile application, which also displays the amount of money saved through optimized energy usage. To ensure accessibility, SMS alerts in the local language are sent in case of faults or low battery levels. As a future enhancement, the system can incorporate polymer coating on batteries to increase their lifespan, reduce replacement costs, and improve long term sustainability.